Hi students, let's look at this important concept here, which is what we call the special angles. These are the angles which are where the exact trigonometric ratios are known. Okay, how do we know these angles? Actually, we're just going to use some basic geometry, so geometrical shapes, and afterwards you're going to use surds, which you've already learned, and some Pythagoras theorem and trigo ratios, right, to be able to deduce these special angles here. Now, what's so special about this is because many times trigo ratios like sine theta and cosine theta, we can't really tell what are the exact ratio, but these angles here, they are special because we can actually tell the exact ratio there. Okay, so the first one is we're going to look at this shape which all of us know, which is the equilateral triangle. Okay, the equilateral triangle. Now, equilateral triangle, we know that the sides are all of equal length, and after which the interior angles are all 60 degrees, right? So this is 60, this is 60, this is 60 as well. So what I'm going to do is actually just going to draw a right angle triangle out of this equilateral triangle. A right angle triangle, because we are talking about trigo ratio. Trigo ratio has to revolve around a right angle triangle. So in other words, we're going to split this into half, just smack in the middle here, and this will give us perpendicular bisector to this base here, and this will be this would then be a 30 degrees angle. Okay, this is 30 degrees angle. So this is just basic geometry, but the beauty about this is now we can have 30 degrees and 30 degrees and 60 degrees here, and if we somehow can find the length of the opposite side of the 30 and the hypotenuse, then we can actually express in the trigo ratio here. All right, so I'm going to write this as 30 degrees. Here will be 30 degrees, and here would be 60. Okay, I'm going to leave the middle one empty because I want it in ascending order. Later on we can talk about 45 degrees, but 30 degrees, or in this case here, this is pi over 6 radian. Okay, or this will be pi over 3 radian. Okay, now so what we're going to do is actually, I typically tell students, let the shortest unit be one unit. So out of all the length here, we have this length, and this hypotenuse here. The shortest length is obviously not the hypotenuse. It will be this length here, and it's not the height of this length here. I'm going to let this length here be 1 unit. So if this is 1 unit, then this will be 1 unit, right? And needless to say, the hypotenuse here will be 2 units, all right? Because this is 2 units, right? If this is 2 units here, being equilateral triangle, it has to be 2 units there. Then the height of this triangle here will just be 2u square minus, okay, you're going to use okay, this height here. Let's say this height here. We're going to use what do you call it? The Pythagoras theorem. H square plus 1u square is equals to 2u square, right? 1 unit. Okay, I can just the u. So can you let 1 unit equals to 2 square? Okay, so the unit, it could be any unit, so you can just let it be one unit length. So this case here, we have h square equals to 4 minus 1. This is 4, so this is 3, so h will just be root 3. Okay, so in other words, this is actually root 3u. Okay, root 3u, so 3 units, and this 1 unit will just be 1. This is 2. Okay, it doesn't have to be, you can just let it be a length of 1, so this will be 2 units, and this is root 3. There you go. This is where we get our exact trigo ratio here. So let's start off with the sine. Now, if you look at sine 30 degrees, sine 30 will be opposite over hypo. Sine is opposite over hypo, OH. Okay, then this will just be AH, adjacent over hypo, and this will just be opposite over adjacent. Okay, so this case here, sine OH will be, sine 30 will be 1 over 2. So this is 1 over 2 over here. Great. Then cosine 30 would then be adjacent, which is root 3. Root 3 here, adjacent of 30, which is root 3, and root 3 over 2. So this is actually root 3 over 2. Similarly, for tangent theta will just be opposite over root 3. So it's 1 over root 3. Here will be 1 over root 3. Okay. Then we're going to look at 60 degrees. 60 degrees here, opposite will be root 3 over hypo, which is 2. They share the same hypotenuse, so root 3 over 2. So this is root 3 over 2. And you have got 1 over 2 for cosine, half. And tangent will be root 3 over 1. Root 3 over 1, which is actually root 3 here. Okay. Root 3 over 3, of course, you could just rationalize the denominator by multiplying root 3 and root 3 on top. This is 1 over 3 root 3. So this case here would also be root 3 over 3 here. Okay, so there you go. That's how we get the exact trigo ratio for all these. So for example, sine 30 will be half. We know that cosine 30 degrees will be root 3 over 2. Okay, that's the nice thing about this trigo ratio here. We know the exact ratios. And it's pretty useful actually. So let's look at the subsequent angle, special angle, which is actually getting it from a square. Okay, you realize that from the first triangle here, having the equilateral triangle, meaning the length are the same, is actually quite convenient. So another shape will be a square here. The reason why it's a square, we can kind of half and force a right angle triangle out of this. And if this length is 1 unit, this is 1 unit. The hypo here will be square root 1 square plus 1 square. This is by Pythagoras theorem, so this is root 2. Okay, now, so the square, it's also another interesting geometrical shape because we know that this is 90 degrees, right? This is 90 as well. So this would be bisected. This is angle bisector, so this is 45 degrees. So this is where we got our 45 degrees from. Or this is pi over 4 radian. Okay, so depending whether you're in radian mode or in degree mode. So for sine 45 is opposite 1 over root 2. This angle here is 45 degrees as well, so it is just the same angle, so it doesn't really matter. So this is 1 over root 2. Cosine would just be 1 over root 2 as well. So sine 45 and cosine 45 have the same ratio, same exact ratio, and tangent 45 would be 1 over 1. Okay, so 1 over 1 would just be 1, right? So this case here is just 1. There you go. So these are all the exact trigo ratios you can get, special angles. So please understand how these special angles are being formed, because it really helps. Sometimes if you find that students don't forget about the ratios, what you can do is actually you just draw it out. Okay, draw this out and try and deduce the ratio by yourself. At least try and draw this out by yourself once, okay, or 2 times, that will be better. So any question or comments, please do let me know, and I will see you in the next question.